All right, everybody, this is 7.1. We're talking about logarithms today. What is a log? Well, logs are just a different way of looking at exponents. So if we're talking about exponents, then we should probably do a quick review of that. And how is that related to logs? So that's kind of like our main goal today. All right, so let's look at this example. 5 to the 5th. What is that? Okay, what do exponents do? So just a quick thing real quick is the 2 is your base, the exponent is your exponent, and your answer here is the argument. We call it the argument, okay? So what do exponents do? Well, exponents tell us how many times we multiply the base, right? So this is 2 times 2 times 2 times 2 times 2, which is 32 would be our argument, okay? Really, like these exponent functions, the base is kind of like the rate. It's how many times, like it's being multiplied every time, okay? It's like a doubling machine. And then the exponent basically tells how many times we double it, right? So kind of think about it like that, okay? These next two examples, sometimes people have a hard time with these. So let's have a look at this and see if this kind of makes sense. So what is our next example? 2 to the 0, okay? So again, what do exponents do? It tells us how many times we multiply the base. So one thing we kind of need to remember here is that we always have a coefficient out in front, okay? No matter what. Even if it's just 0, you could have a coefficient in front of that, okay? Or if you just had x, we could put a 1 out in front, okay? So there's always a coefficient in front of any base. So again, in this example, it would have to be a 1. So again, what do exponents do? They tell us how many times we multiply, okay? How many times we multiply by 2. So that's telling us that we have no base, none of the base. It's not multiplying the coefficient by anything. So our answer here is just 1, okay? So for example, if we had x to the 0, again, that's telling us that we have no x's, but we always have that coefficient. So this would just be 1, okay? In this unit, I think all of the leading coefficients will always be 1. But if not, if we had 2x to the 0, then our answer here would just be 2, right? We're not multiplying 2 by any x's, okay? But again, most of the time, it'll just, I guess all the time for this unit, it's just going to be like this invisible 1 in front, okay? All right, our next example is when we have a negative exponent, okay? What does that mean? So when we talked about, well, when we did like this example, it was how many times we multiplied, right? But when we end up with a negative exponent, it's a little different. How do you multiply the one, like -1 times, right? That doesn't really make sense, okay? But if you really kind of think about it, when we have a positive exponent, we end up multiplying every time. If we're going the opposite direction, we would end up dividing, okay? So again, this would be 1 time, or divided by 2. Or if we had 2 to the -2, we would end up having 1 divided by 2 divided by 2. Okay, so that's a way you could think about it. I think maybe the easier way to think about it is by just like, sorry, my voice is a little off. I think last year when we did this problem, we kind of had a table, right? And we did something like this. We started with like x to the 3, and then x to the 2, or we could even just do 2's. So 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, 2 to the -1, 2 to the -2, okay? And then we evaluated those. And here we ended up getting 8, and then 4, and then 2, 1. And what's happening here is it is getting half as big, okay? So that means the pattern, if we keep going, this would have to be 1/2, right? Half of 1 is a half. Half of a half would be 1/4, okay? And if we continue, 2 to the negative 3 would be 1/8. Okay, so if we kind of think about that way, is we end up getting the same number, but when we have a negative exponent, it's almost like it's reciprocal. So we end up having 1/8. Or when it's -2, we ended up getting 1/4. Okay, so for this example we had would be 1/2. Okay, so kind of think of it as if there's not the negative, and then the negative will make it be 1/. Okay, like it's reciprocal. 2 to the 1 is just 2, but when we make that negative, it's going to make it be its reciprocal. Okay. Anyways, we'll give that a try. All right. In class, we kind of filled this part in. If you want to give that a go for it. We're going to maybe compare it to this g of x to the right side and see. Okay. But now let's kind of talk about logs. Okay. So here is an example of a problem using logs. How we would say this is log base 2 of 32 is equal to, and then we want to write down our answer. Okay, so we're using the same sort of values. This is exactly the same as the example over here. It's just in log notation or log form. Okay, so what this is actually asking you to do is it's saying 2 to what power, so maybe we could rewrite this, 2 to what power is equal to 32. Okay, so our answer should be an exponent. Okay, what would be the exponent that you need? Okay, so for this one, we would need it to be 5. Okay, let's try another example. I think the next one, if we go over here, we would have log base 2 of 1 is equal to what? Okay. Again, this is saying 2 to what power is equal to 1? And here our answer would have to be 0. Okay. So again, these are literally the same type of equations. It's just instead of asking you to solve for the argument, logs ask you to find the exponent. Okay? They're just solving for a different part of the equation. Let's try the last one. So log base 2 of 1/2 is equal to what? Wait, did I do that backwards? No, I did that right. Okay, good. Okay, so again, this is saying 2 to what power is equal to 1/2? Okay, and that would have to be a -1. 2 to the -1 is 1/2. All right, and then we went over and filled in this table. Again, we're doing kind of the same thing. We're taking these values in here, and we would say log base 2 of 1 is equal to what? So 2 to what exponent would give us 1? And so we would end up getting 0. 2 to what exponent is 2? And that would have to be 1. And we kind of went through that process, okay? Really the takeaway here is when we look at these two tables, you're going to see that the values are the same, just your x and your y's are swapped. Okay, and those are called inverse functions. So if that ever happens, I think we actually did this with the radical functions when we had something like y equals x squared versus y equals the square root of x. Those are inverse functions, okay? If we were to write a table for these values, you'd end up getting the same sort of thing, okay? Or similar. Maybe this should be a plus or minus. All right, going on. We kind of filled this in. Most of this, I think, is very similar to what we've already been doing, except for this middle part, okay? So fractional exponents. So one thing you need to make sure you understand here is that anything to the 1/2, an exponent of 1/2 is equivalent to a square root, okay? So they're just different forms. This is radical form, this is exponential form, okay? Just a different way to write the same thing. So if you ever see a square root, or if you ever need to square root a number, we're going to be using, we're just going to be using an exponent of 1/2. Okay, so we'll probably come up with some examples of that in just a little bit. Okay, so let's kind of go on and do some of these examples. So this is kind of just getting you into the process of finding the exponent. What is the exponent for these problems? And then we're going to go and look at log functions, and that's really what you're going to see on your homework, okay? So some of these problems are probably a little harder than what you're going to even see on your homework, but I think it's good to stretch yourself a little bit, okay? And then it will make the homework and the test even easier. All right, so I'm going to do a couple, and then I'd love it if you would pause and try a big handful of these, and then come back and see how you turned out, okay? So here's a couple examples first off. Oops. So this is just saying, what would have to be the exponent? 13 to what power equals 13? So here, x would just have to be 1, okay? D, 14 to what power is 1? Okay, again, that would have to be, oops, I'm going to mess that up. X would have to be 0, right? Because anything to the power of 0 is just the coefficient, right? So we just get 1. Okay. How about E? Let's skip to E. 81 to what power gives us 9? Okay, so what is the relationship to give us a 9? And it would have to be a square root. So just a reminder that a square root is the same as an exponent of 1/2. Okay. So here what we'd want to do is we would have to say that x, is that x has to be 1/2, okay? Because the square root of 81, or 81 to the 1/2, is equal to 9. All right. And then maybe let's look at this one, and then I'll have you pause and see if you can do some of the others. So 10 to the what is 1 over 100. So again, let's first talk about this. What do we have to do to 10 to give you 100? And we would have to square it, right? That would give us 100. But what's going to make it go to the denominator? What's going to make it do its reciprocal? And that would be the negative. So x here has to be -2. All right. Okay. Okay, so pause, try and come and do some of these others, and I'm going to kind of go through these pretty quickly. All right, so this would have to be 2, because 7 squared is 49. This one, again, it's already 4, but we need to move it to the denominator, do its reciprocal, so that means that x has to be a -1. Okay, so the 1 by itself isn't going to change anything, but the negative is going to make it be its reciprocal. All right, 2 to the what is 32? Again, we'd have to do 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So x would have to be 5, right? I, 36 to what power gives us 1/6? Again, we want this to be a 6, so x has to be 1/2. So that would just give us 6, but we need it to be its reciprocal, so it would have to be -1/2. Okay, again, it's like we're square rooting of 36 is the same as 36 to the 1/2. Okay, that gives us 6, but we need to do its reciprocal, so that means our exponent has to be negative. Okay. All right, I think we were missing one over here for G. What do we need to do to this to give us this? We would have to square it, right? Because 1 squared is 1, and 4 squared is 16. So x equals 2. J, again, it's a little more complicated, and I'm not sure how many of these you'll have, but we don't want a square root, right? We just have a 3 over here. It's in the bottom, so we're going to end up having a negative exponent. But to get rid of that square root is we would need to square. So that would just give us 3, but we don't want 3, we want 1 over 3. So it's got to be a -2. So x is -2. All right. Here's one very similar. We just want 5, but we've got the square root of 5, so we'd need to square to cancel that out. So x has to be 2. L, again, we don't want a cubed root, we just want just the 2, so we would need to do its opposite. X would have to be 3. Because a cube and a cube root are inverses. Okay, and then finishing off, these ones are pretty easy. The only thing that's really kind of different here is instead of having a rational number, here we have an irrational number like pi. Okay, but it's pretty simple. What would x have to be? It would have to be 3. Then it's the same. So if they have the same base, we're really just matching their exponents. Okay, so here's like another example. X has to be pi. Because if they have the same base, then their exponents have to be the same as well. And then our last example, we want an e squared. So this has got to be a 2. But we need it to be in the denominator, so we'll do its reciprocal. So exponent would have to be a -2. All right, so I kind of went through all of that. Now let's get into logs. Again, this is what you're really going to see on your homework. Again, what are logs? They're asking you to find the exponent. So 3 to what power would give us 3? Okay, so that comes from here. That's our argument, our answer. We need to find its exponent. So here x would have to be 1, because 3 to the 1 is 3. 11 to what power gives us 1? Well, x would have to be 0, because 11 to the 0 power is 1. Okay, let's kind of go over here. Again, this is saying 5 to what power is equal to 25. So 5 to what power is 25. So x would have to be 2. And this is a little trickier. 25 to what power? Okay, 25 to what power is equal to 5? Okay, so what would we have to do? We'd have to square root. But again, we are writing it with exponents instead of roots. So x has to be 1/2. Okay, because 25 to the 1/2 is the same as the square root of 25, which is just 5. All right, we're almost there. 6, again, that's our base. To what exponent, that's our exponent, our right side, is equal to 1/6. So x would have to be -1, right? So we still want it to be 6, we just want it to be its reciprocal in the denominator, so it has to be negative. And then here we've got 2 to what power would give us 8, and x would have to be 3. All right, these last two, just a little different. Instead of numbers, they might be pi's or e's. Okay, we'll talk more about this number. E is a number. It represents similar like pi. Okay, so again, this is saying e to what power? So e to what power is equal to its argument, which is e. So x would have to be 1, right? Because e to the 1 is just e. All right, almost there. 10 to what power is equal to 1/10? Or sorry, over 100. I think we've already done this one before. So again, x would have to be a -2. And then our last example, 16 to what power would give us 1/4? Okay, that's probably the hardest one here. So how do we go from 16 to 4? That would be like the square root, but again, we write it as 1/2. That would just give us 4, and then to have it go in the denominator, it'd have to be a -1/2. So x is -1/2. Okay. All right. So logarithms or logs output what? They output exponents. So all of our answers are exponents. I can spell it while I'm talking. It's kind of hard. Okay. All right. So the rest of it, we're going to talk about how to switch back and forth between logs, like log form and exponential form. Okay. So just a reminder on inverses. We've done this lots of times. It's just going to be a little different since we're doing logs instead of square roots or adding or whatever. So the opposite of subtracting, again, we're trying to get y by itself. So its opposite or inverse operation would be adding. So we could add both sides and we would get y equals x plus 2. Okay? So those are opposites or inverses. Okay? This equation is being multiplied, and its opposite would be to divide. Sorry, I don't know why that happens sometimes. We'd end up getting y equals x/3, right? When we get to squaring, what's the opposite of squaring? Would be square rooting. So y equals the square root of x. It really should be plus or minus. Okay. The opposite of square rooting would be squaring. Okay, so those are inverse operations. Okay. Just like that, there are opposites for logs. Okay, so the opposite of log base 2 is a base of 2. So log base 2 cancels out a base of 2. So our answer here would be 2 to the x equals y. Or you could write it the opposite way. You could do y equals 2 to the x. Okay? This is really good when we're trying to just solve for, like, if we know what x is, to give us our answer in that order. If we're like graphing or writing an equation, oftentimes we'll write it in that way. okay? So what would be the opposite or inverse of log base 3? Well, that would be base 3. Again, we're making the top, like this part, become your exponent. Okay, so again, you can do whatever you want as long as you do the same to both sides. Okay, and that cancels, so we end up getting y equals 3 to the x. Okay, so that's kind of like the basics, and then let's go and do it the opposite direction. What if I give you an exponential form, and we want to switch it to logarithmic form? Okay, so again, the opposite, if the opposite of a log base 2 is a base of 2, then the opposite of base 2 would be log base 2. And we'd have to do it to both sides. Again, log base 2 and base 2 are opposites, they cancel. So we would get y equals log base 2 of x. And again, you could write it, sometimes you'll see it this way, in this order. Okay, both are great. All right, and then the last one, here the opposite of a base of 5. We want to get rid of that, so we could do log base 5. We have to do it on both sides. So y equals log base 5 of x. All right, so let's go and we're just going to do a little more examples of that, and then we'll be done. Okay? So again, our goal here is to put it into log form. That means we're going to try and get rid of the base. So the base here is 10, so we would want to do log base 10 on both sides. That would cancel, so we'd get log base 10 of 100 is equal to 2. Sometimes they'll put it on a parenthesis, the argument in a parenthesis, especially when you do your homework. Sometimes it will automatically do that, so just be aware of that. Okay, let's look at this one. Again, we're trying to get rid of the base, so we would do log base 3 on both sides, and we'd get log base 3 of 81 is equal to 4. If we do D, again, we're trying to get rid of the base, so we would do its inverse, so log base B. So we'd end up getting x is equal to log base B of C. So this is just kind of generic, like it could be any number for B or C. Okay, and then I think our last example here, get rid of the base by doing log base 3. And that's just our answer. So log base 3 of 1/9 is equal to -2. Again, the order of those, if you want to have the -2 first, it would still be fine. All right, switching the opposite direction. Again, I feel like this goes a little quicker. You don't have to do as much writing. We want to get rid of the log base 2, so we would do a base of 2. That would cancel, and that's what's left is our answer. So 2 to the 5th is equal to 32. Here we'd do 49 and 49. This would cancel. So 49 to the 1/2, which again is just a square root, is 7. Going over to the right side. Again, we'll do a base of 5. Here's something we should talk about first, okay? So you could do that, but here we already have, well, I don't know. Maybe this one's a little confusing. Yeah, let's keep going the same way. This would cancel, so we'd get 5 is equal to 5 to the 1. And obviously that's equivalent. Base B, C is equal to B to the X, or again we can swap that, B to the X is equal to C. We're going to skip F. We'll talk about that next time. And then this last one, again, get rid of the log base 2 by putting a base of 2. So we'll get 2 to the negative 1 is equal to 1/2. If you want to give this a try, you're welcome to do it. It'll be filled in on the filled in notes, but you do not have to do that, just if you want some extra practice. And then this will be helpful when you get to the homework, the first part of the homework. Okay, just again, what are those are called, each of those parts of these equations. Again, the answer for a logarithm is always its exponent, so that's what we're solving for. Okay, logs output exponents. Okay, and then one last thing on your homework is when you need to do a base, like base of b log base b or log base 2, there is a little part on your homework or on the that will have a little thing that you can choose to do a base, and it looks something like that. Okay, so you'll just type in log, you'll push this, it'll make a place for you to put your answer here. Maybe it's 2, I don't know. And then you'll have to push over so that you can put in the argument. Okay, so whether it's 7, I don't know. Okay, or maybe it's 8. And then you could write down the equal sign, and then for like this one, maybe it's 3. Okay? If you have any questions on how to type that in, just come and talk to me. All right, we'll see you later.